This is Lab 6, Investigation 2, Voltages in Parallel Circuits. We have here two light bulbs, a switch, and a battery pack. Again, I'm using two batteries together so that there will be enough voltage to light these light bulbs. And these two batteries are in series. When I connect it, you're going to, well, I want to have you make a prediction first. I'm going to open this switch over here. And this is the prediction 2-1. I'm going to pause it. I want you to make that prediction on page 111. And you pause your video as well. All right, go ahead and make your prediction for 2-2. So turn the page 112, and pause and make your prediction. In both cases, we're predicting what's going to happen to the voltage across this battery pack here when we open and close that switch. And what's going to happen, how will the voltage across this first bulb compare to the voltage across that battery pack? So pause your video and make the prediction on page 112. What we've been learning about parallel circuits is if I attach this right here, we can see the light goes on. And when I close this switch over here, I'll put these bulbs a little closer. I'm expecting this other one to be about equally bright, and that's not the case. I'm also expecting this first one not to change its brightness that much. So this would be like in our classroom when we turn on one set of switches, and when we turn on the second switch, we don't expect that first one to go dimmer and that other one to be also not as bright. So what's going on here? These wires are awfully skinny. So I'm going to try to make a thicker wire just by doubling up. I'm making, instead of one wire, I'm going to double up two wires and two wires. And we'll see if that makes a difference. All right, so that looks like an ugly mess, but all I've really done is where there was one black wire, I've made two black wires. And this side of the bulb there is connected to this part of the bulb that's also connected all the way back to the negative terminal of the battery. Here where there's one wire, I've doubled it up. I ran out of red wire, so now I've got a red and a white one going to the switch and over there. And when I close it, let's see. Oh, yeah, take a look at that. Those look like they're a little bit almost equally bright. And that first one, yeah, it gets a little bit dimmer, but the change isn't as drastic as before. Well, you can imagine what would happen if instead of just having doubled up wires, if I tripled or had 10 wires there and 10 wires ever. If I just had a thick wire, then it'd be a lot more like our classroom where I flip the switch and that first one doesn't even change its brightness and that next one is just as bright. And that's more the case of what happens in your house when you turn on a switch or turn on something that's plugged into the wall. The other things that are in your house, they don't go a little dimmer or run a little bit more slowly. We're ready to take some measurements for activity 2-1. So what I'll need to do is I'll need to connect these voltage sensors and zero them, and then we can take some measurements. I've opened up file, file lab 6 activity 1-2, as the instructions said. And I've also inserted a couple of digital meters so we can see the values a little bit better rather than looking in the top left-hand corner. We can see it here. So the first thing I need to do before I use my tools, I need to make sure that they're reading accurately. And right now, to zero them, let's recall, I want to say that there's no potential difference or no voltage when these are joined together. They're at the same spot, so the red one should be reading the same as the black, and the difference should be 0. I'll connect this one as well on my other one. All right, so I've got both of those connected, and when I look at my screen, well, it's close to 0. It's within 0.02 of 0, but we can do better than that. And so let's go ahead and zero both of them. Wait a couple of seconds there. Now they're within looks like less than 1,000. It's about 1,000th, within 1,000th of 0. So now we're going to put one of the probes for activity 2.1, I'm going to put one of the probes on, let's see, as in figure 6.7b. So one of the probes is going to go across the battery and one is going to go across bulb A. So I'm going to put one of the probes here and the other one across this one. I'll put the red lead there and the black lead here, the red lead there and the black lead there. What an ugly tangle of wires. It's good that we started off just with no probes and single wires. So we've got the red coming to this side and then going over the switch. Then we've got the black on this side coming back over here. I've got one probe attached to the battery. I've got the other probe attached to the bulb. But I don't know which probe is which, and I'm not going to tell you. I'm going to allow you to use your clues, what you've learned in the previous activities, to try to determine which one of these voltage probes is reading across the battery and which one across the bulb. So now I'm going to do step 4. I'm going to start graphing and open and close the switch. So I'm going to hit the space bar. I'm going to open and close the switch. And the 10 seconds are up. That's what my graph looks like. And now I'm going to get ready for the next activity. This file I will make available. This will be run 1. So I'm going to store this as run 1. Or maybe I'll store it as step 4. That might be a little bit better. I'll store it as step 4. And then I will collect data for step, let's see, for step 7. That'll be for the next page. And I'll provide this data file to you. Hopefully you haven't opened that data file yet and you've done your predictions without looking at it. But go ahead and open them up now. And the first one, the first run should be step 4. If it's not, you can check, use and see that it's step 4 and not step 7. And pause this video and go ahead and make your graph and fill in step 6 for, so do steps 5 and 6 on page 112. So pause your video and fill out those steps. Now, while you're doing that, you had to determine, or in order to do that, you had to figure out which one was it, voltage 1 or voltage 2, which was your battery and which was your bulb. I want you to change that sensor for the bulb. Go into the column, go into the software and change the name of that column. Instead of voltage 1 or voltage 2, whichever one you thought it was for the bulb, call that voltage bulb. Because I've kept that sensor the same. I've changed the one that was on the battery and I've moved that over to the second bulb, to bulb B. So I want you to say then voltage bulb A for the one that you think that was. And the other one you can just leave it as voltage 1 or 2, because in the first run it's going to be for the battery, and this second run it's going to be the voltage for bulb B. You can keep the axes that way if you want to. That's similar to how it's in the book with -5 to +5 volts. Or you can adjust the axes for optimum presentation. I'd like you to annotate when the switch was up, switch was open, and when it was down. So insert some annotations for a couple of spots for where you think it was open and closed. And now you can make, then it doesn't look like there's a prediction for the next one. So I'm going to go ahead and collect data for the next run, and you can then, well, let's take a look at that. So I'm going to collect, I'm going to reconnect. Anytime I'm not collecting data, I disconnect the battery just so it doesn't waste the energy of these batteries and preserves the bulbs a little bit. So I'll reconnect that and collect data. Hit the space bar to collect data. And I'm going to open the switch, open the switch, close the switch, open the switch, closing the switch, And we've got our data for the next run. So I will store that run as step 7 for this activity, and I'll provide this data file for you. You want to then go and hide the step 4 run and show the step 7 run, and then use that information to fill out your graph, step 8, and the information for step 9. And on that graph too, go ahead and annotate where was the switch open, where was the switch closed. I'll go ahead and, or I want you to pause. I want you to pause this video and go ahead and fill out that information. Before going on to activity 2.2, I want you to finish all the questions for activity 2.1. So you're going to put in your information from your graph from both runs. You're going to answer question 2.2, 2.3, 2.4, 2.5. 2.6 is a little subtle. What is the voltage between 2 points on a short length of wire when there's no bulb, battery, or resistor between the points? That's asking, kind of saying, what's the voltage between here and here? I've got this tangled mess of wires, but imagine that was just one wire. What's the voltage from there to there? Or the voltage from here to here? And it's very similar to question 2.3 on page 69 back in lab 4, where we did a measurement. We measured what the voltage was across a single wire when we open and close the switch. So you can refer back to page 69, question 2.3. And that might help explain some of the results that you got. So at this point, pause, or this video is over. Before you go to the next video for activity 2.2, finish all of those questions for activity 2.1.